Okay, everyone, let me know in the chat box. Let me know give me a thumbs up if we are good to go. You can hear me clearly, and you all are great. Right, great. Ramesh, okay. Let me open the collab. It's cool, folks. Yeah, I believe you can see my screen. So today we'll start with NumPy, one of the library. So we have done some basics, right? Just to put you in place, and the thing is, put your concept into the place. And I believe most of you are now somewhat comfortable with the. This was just a revision, the what we have been through in Python, right? And point was just to, you know, show you this stuff. I believe, yeah, we can start now. This after this, we'll go to some libraries. The libraries which make Python, right? Which makes Python, like Python for database, right? And in that line, we'll start with the very important library, NumPy. Okay, just a minute. Okay, so NumPy, if you ask me what sort of library this, why we need it, it is, the name is numerical Python, and it's being just somewhat, some people would say it's for calculation, right? Numerical Python, numerical as in numbers. So for doing the math in Python, right? One reason is this numerical Python. One reason is for calculation, mathematical calculation, scientific calculation. Do not mind my spelling. Mathematical calculation, I believe you can feel it. Mathematical calculation and spelling as in handwriting. And scientific calculation. One reason is this for this scientific calculation. And one second reason is NumPy provide the most important reason. For calculation, of course, we can do a lot of stuff. Okay, other libraries as well. But second reason is important. NumPy provides you NumPy array. NumPy provides a data structure which you can use in Python, which is array, NumPy array. So list was okay. List was okay. List is amazing, heterogeneous as well, popular as well, right? And handy as well. But the point with the list is slow. It is slow. Right, and plus it is dynamic in size. Sometimes if you just need to add something, you have to just, I believe, there's a logic, double the size or something. So it's a dynamic size. So we need something which is compact and faster. And C++ has that data structure, which is array, right? So NumPy library, why NumPy library? We can use C++ array. So it provides a data structure, NumPy array or array for that data. This is the second most important reason. True, guys. Now your point is why we need array for that matter. Why array is so important. In fact, afterwards you will see, whatsoever data you will see in uh, in fact around you can be represented. Every data can be represented as array, whether it's a normal file, whether it's a image file, whether it's a text file, right? Whether it's an audio file, whether it's a video file, what is the spelling of video? Video file. Everything can be represented as a array. So I can say that fundamentally all this data, every data is array. So that's why NumPy makes its NumPy library is very important. So with this library, you can know how to tackle these all data, and we'll tackle these in machine learning, deep learning. True, guys? Shall I show you how an image file is a array file? Is array fundamentally array data structure? So there, give me a thumbs up if you're excited for that. So I'll show you some data set, image for that matter, image data. Right, this is a grayscale image. Grayscale is in colored image of handwritten digits. Handwritten digits. Right. This is a data set of handwritten digits, 60,000 such images. Somebody take black and white images of how you like write five or something. Right. And even one five, if I just go to any five of this, any image five, this is how it looks. Uh, this is how a image file is looking. Can you see this? This is an array. Or if not array, can you see it's a table, rows and columns. And there are values here. In fact, machine sees the image like this only. Machine can understand this is a shape. If you can feel it, how machine might be feeling it, just feel it. Can you see the shape is where the color is not black. Wherever the color is black is the background. And wherever it is white, it is not the background. And if you just check properly, the numbers inside the white color are bigger than the numbers here. So this is almost 0, 0, 0, 0 or negative. This is like positive. So intensity here is more. Agree or not? This is how uh, maybe this is how the systems can recognize the shape. And if it can recognize the shape, it can recognize the image. Agree? If it is a yes, give me a thumbs up. This, folks. So my point was just to show you. Do not worry. We'll see this sort of example earlier. Again and again. This was just image file. How it can be a array? Does that make sense? Can you observe it? Yeah, folks. If any doubt, DM me. You feel that this sort of some tough or is easy or interesting? Interesting, na? In fact, not this. Many other files. In fact, colored image. Shall I show you colored image? In fact, this is how a colored image is actually, right? So of course, this is in channels, different channels, red channels, RGB channel, and then you get some colored image. And in every channel, it is just a grayscale image, like this, having numbers in an array. So colored image is actually grayscale images are 2D array, a sheet only. Colored images, many sheets. True, but eventually they all are arrays, some combination of arrays. So that's why array is important. If that reason resonate with you, let me know. This was just why we are doing this. Of course, the why part will be more clear as we move throughout the course, right? Because for me, the last stage of philosophy is why. Okay, so this is why we are doing, why we are learning NumPy. True. Now the point is how to import NumPy and how we can create our first NumPy array. So import NumPy as NP into this. So if say for example you have, it will take some time. I'll create my first array then, NumPy array. Folks, any question you have till here? Or you're okay with this? You can at least give a thumbs up. Voice, girls. Am I mute? Am I on mute? No, I'm not on mute. You people are right. We are great. Now the thing is, array is done. So say for example, there's an array. You just need to do this first function, np dot array, create an array, and I'm passing a list 1, comma 2, comma 3. So this is my first array, and this is how array looks. In fact, if you just put the type of a, right, numpy and dimensional array. This is a numpy array, right? So first way, I can just create an array by this only, just np dot array, this function. Can I create a two-dimensional array? This just look very plain. I know one line. Can I create in many lines, which you call two-dimensional? Okay. Yeah, we can do that as well. Agree? So this is this sort of array, which you also call vector. And what I'm going to create is a matrix. Okay, np dot array. Say for example, 1, comma 2, comma 3, comma 4, comma 5, comma 6. Did I messed up with something? Array spelling is okay, no? Yes. So yeah, this is, you can say that in this array, you can say that I have two rows, right? In the first, I have only one rows. In the second, I have created two rows. And let me create something else, right? Like 1, comma 2, wait, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8, comma 9, right? And one more thing, I just add one more thing into it. Let's see what does something I again messed up. This one more. Let's see. No, this array is different. And just check the number of the brackets. Okay. This is having one, this is having two, and the other single one was having A1 was having not like any, right? Apart from this is having nothing. Apart from this is having one enclosing bracket more. And apart from this is having two enclosing bracket. So what does that mean actually? So first array is 1D array, second is 2D, third is 3D. So how you read it, 3D or 2D? So even there is a function, right? Don't worry. Slowly you'll understand why there is a need of 1D, 2D, 3D. Okay. Though I've shown you black and white images, grayscale images are like one 2D array, 2D array. Colored images are many 2D array. So they are 3D array. Right? You're getting my point. So the thing is, it's just like you need to add one more feature. So of course, colored images has one more feature na, than black and white images. So of course, everything is monochromatic only. So you whatsoever color you get in life, it is also the combination of RGB. You agree with this or not? Primary colors, red, green, blue. If you agree with this, give me a thumbs up if you have known around about it. And that's how we would also get every colored image, right? With some composition of them, you will get in every color, right? So the thing is, if you have one channel only, one channel as in red itself is a black and white only. Black and white is as in you have only two options. Whether it's there, it's not there. Binary. Agree or not? That's why I say grayscale image. So if you have only one option, red, whether red or not red. This is also like whether white or not white. Agree or not? So one channel of this, one channel of this, one channel of this. So this is like many one single color, you are making multiple color, right? So these colored images are nothing just but a combination of this, right? So many 2D can make 3D, like same like you know, like in physics. Let's go to the how. Let's understand the world, and whatsoever the world is there, we have to just implicate in the digital world. Okay, so I'll come to the very basic point so that you all understand what is dimension, right? Let's create dimensions. Just for some minutes, everyone just pay attention. What is zero dimension? So maybe this point is zero dimension. Agree or not? Zero dimension. It cannot do anything. It cannot move, right? Then so dimension comes with the movement, right? Just a minute. So we'll have more space. What is one dimension? How do you define one dimension? Many zero dimension, many point. A point is a zero dimension. Many point, if we just put them together, this makes line. Or line is a one dimension. Agree or not? Line is one dimension as in you can move forward, backward. What is two dimension? What can be the two dimensional world? Many line. Many line can make a plane. Agree or not? Many line can make a area. This is 2D. True or not? What is 2D? Instead of apart from moving forward, backward, you could also move left, right. So where you can move left, right? In a plane, forward, backward, left, right. Then what is 3D? What is 3D? Guys, you can participate. Many 2D, many sheet together. Put many sheet together, you'll get a 3D. Agree or not? Put many sheet together. This sheet, 3D. Right or not? What is 4D? Many 3D together makes 4D. Of course, we cannot visualize 4D, but are you getting the point? How we are moving from one dimension to the dimension. So, you know, same for others. And if you add features, there might be some new features. No? So that's why, of course, in your data, in your digital world, you have many dimension. You can go 1,000 dimension as well, because each dimension might represent some feature. Like when you're moving from 2D to 3D, you get colored image. When you move from 3D to 4D or something, you get maybe videos, running image. When you go from 4D to 5D, you might may get what do you call it? HD images, HD quality, audio as well into it. If it is till here, it is a yes. Give me a thumbs up. Dimension you're getting, na? You are feeling, na? This is actually mathematical concept and abstract. And maybe from some points would come. Of course, in machine learning and stats, things would become abstract. But if you can feel it, abstract as it philosophically, but it is actually the real thing, what you are seeing in the world, right or not? The very real things are very abstract. Okay. So this is abstract math, but I believe you're getting more. So we are living in a 3D world, right? How do we see the world? 3D or 2D? What is your POV? 2D. Agree or not? Okay. Now we'll come to it afterwards. I believe you're not. So this is now the thing is this is how we can create array. Till here, guys, everything is fine. Give me a thumbs up. If you have any question, you can DM me, right? I was about to go more into it, but now I'm just restricting myself, right? Yeah, but everything here, what we are going to discuss, make has a realistic application use case. B dot endim is this two dimensions. C dot endim. Let's see this. What is this? Three dimensional. And how to read this C three dimensional, right? Uh, I'll tell you one thing. Actually, it is one array of 3 cross 3, one sheet 3D. If I take so many such sheet, there is a space as well for this. Then it will 3D. I'll connect it with you in some time, because typing it would take more time. So I'll show function by which we can do it very easily. Okay, for the time we will hold it here only. Okay. Now Till here we have just created array, okay, of a particular data type. Can we control the data type as well? Yes, we can control the data type as well. As I'm saying, and np dot array, right? Say for example 1 comma 2 comma 3. You can give a data type as well here. Data type, say for example, is equal to bool. Then it would be np dot boolean. Your elements would be boolean. Np dot array, and say for example 1 comma 2 comma 3. You can also give data type here as, I believe, complex number. You know, if you know, give me a thumbs up. Complex number. So I'll ask you one thing. Numbers are 1D, right or not? Numbers are 1D. But complex number are such numbers which are 2D. How come? So this is the beauty of math. The thing is, whatsoever numbers you might have learned so far might be on a number line, right? A number line. So numbers are 1D only, right? But complex number are being presented, can be presented in a plane. So this can be a complex number, right? So 2D numbers are complex number. So I'm assuming you know complex number, but if you fun fact about complex number, it is there too, right? Same for, you can just go for 1 comma 2 comma 3 comma d type is equal to float as well. So this is float. So you can even control the data type of the element. This I was trying to show you, right? So this was about the data type. With respect to this, now we are just learning how to make array, right? As it is so important data structure, that's why I'm just trying to show you everything about how to create, right? What is array? How, what, and how. Why part is big. In any philosophy, why part is the big and challenging one, and the thing is one you should look for. No thing is, there is one function arrange. You remember in list there was a function range, right? Let me turn off the AI here. Else it would interfere. Okay, right. So the thing is, like range in list, there is arrange here. So np dot arrange, if I just put 1 comma 10, you'll get what it would do. It would create an array from 1 to 10 with a jump of 1, right? You want to create an array of just odd numbers. So 1 comma, say for example 20 comma 2. So jump is 2. Can you feel it? What would happen? Odd numbers array. If it is a yes, give me a thumbs up. Easy. Right. Now I'll show you one thing. When I was creating array and multi-dimensional array, if I need to create, it was tough because we have to type and worry about these brackets and all. So how to do this easily? There is one more function. Let's talk of this shape. Right? Shape. With shape, what I can do? np dot arrange. So say for example 12, right? So it will take from 0 to 11 all numbers. 1D array. It will create first 1D array like this. True? 0 to 11. np dot arrange from 0 to 11 all the numbers. Then I'll put reshape 3 comma 4. 1D array, it would convert into 2D array of 3 rows 4 columns. 3 rows 4 columns. So all this 1D would be converted into 3D 2D 2D. Can you see this? Easy. np, let me create np dot arrange, say for example 27. Reshape 3 comma 3 comma 3. Now it is easy. Now feel it. Feel enjoy. This is B. This is B. Earlier I just created 1, And how it has been created? You can say that the dimension is, this is 3 array, 3 comma 3. How does it read? Feel it. There are 3, 3, 3, 2D array. 3 as in 3 numbers. 1, 2, 3. 3 2D arrays of 3 cross 3 dimension. Can you agree with me? Do you agree with me? There are 3 3D array, 2D array of dimension 3 cross 3. Now this is one 3 cross 3 dimension array. This is again 3 cross 3 dimension array. This is again 3 cross 3 dimension array. So you are just putting 3 2D array of dimension 3 cross 3 of shape, sorry, of shape 3 cross 3. This. So this is a 2D array, this is a 2D array, this is a 3 sheets. 3 sheets making is 3D. Right or not? B dot endim. So this will be 3 dimension. Agree or not? And as I told you, sheets, arrays. You put this sheet, which is 2D, this sheet. Each sheet is 2D, 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 and shape is 3 cross 3. Makes it a 3D array. Right, folks? If it is a yes, give me a thumbs up. Till here, I believe we are okay. Right. Now there are more into it. I just quickly show you others as well. So we can create np dot once, right? 3 comma 4. Okay. So these syntax error would keep on coming. So this is a 3 cross 3 dimensions array of 3 cross 3, 3 cross 4 shape. Dimension is 2D only, right? 3 cross 4 shape 2D array having ones only. Same you can do for zeros. And we use them. Now you might feel where we use these ones array. And my answer is in deep learning also we have used these arrays, ones arrays, zeros arrays. When we do the deep learning, of course, if you do, I'll show you. But in deep learning, we have application of these sort of arrays as well. Zeros, ones, right? So it is an array of shape 3 cross 4. Very easily we can create, right? Now let's create something more into it. There is one more function, np.random. Very famous. We'll use them from here a lot. np.random. As the name suggests, it would be a random numbers. Because, till here we are very certain it's not coming like randomly. And, these all things matter when the things are random, right? Numbers are randoms. Your situations are random. So for that, random.random, right? np.random, it is the function. Let's give the shape 3 comma 4. So it would be a 3 comma 4 shape, a random array. Agree? Agree, folks? Right. In fact, you change it, it can be anything there. So it's not a 3 comma 4 only, it can be 3 comma 3 as well, right? But all the numbers will be from 0 to 1. Fraction. Same, there is another important np dot linspace. So for that np dot linspace, you go from -10 to 10. Say for example, you will go for 20. 20. Now see what is happening here. First of all, I'll wait here. Till here, everything is fine. Is it not like that I'm rushing now? I was rushing because some things are easier, right? So I'll wait for a few seconds. If at this moment things are digestible, give me a thumbs up. Or you have any confusion, DM me. Okay. Now I'll come to the linspace. What is linspace is doing? As the number suggests, line. It is just like dividing from negative 10 to 10, this part of the line, into 20 equal parts. That's it, simply. So negative 10, it started from there to there, it divided from there to there, another part from there to there till 20 part, right? You can also give like 100 to it. So this much line you have, how much equally, equally distance, and it is equidistance as well. Equidistance, small point you would have, like 100 you have. Can you see this? You can create a 1D array. This is a 1D array having numbers from negative 10 to 10, equidistance number. Cool, guys? Equidistance, you can feel it. Equidistance, equidistance, equidistance. So what is just happened? Negative 10 to 10. And you have divided into 100 equal parts. That is line space. Sometimes just to create random arrays, just to create this sort of the bizarre arrays. And it is important. Sometimes random data is important. In fact, you'll find most of the time random data is important. Agree? It's just like if you can perform better over random questions, you would be able to perform good. I believe that makes sense to you. Right. Shall we move? Okay. Then I have not, discussed this thing, like I believe attributes. Let's just focus on array attributes. No, attributes. And let's make things somewhat more easier and interesting. Okay. And so for that, I need to create some array. And say, for example, simple, same way. A1 is only area and period. A2 is equal to mm, 4 comma 3. A3 is equal to range, say for example, 8, or reshape to come to model. So this is A1, this is A2, 2D. Then what? This is A3. Right. Two rows, two array of this dimension, 2 comma 2. You can see this. There are two array of 2 comma 2 dimension. You have two example of two arrays of dimension same. So this is about this thing. But what are the attributes? Attributes are as simple as that. Ndim, like I shown you. Ndim is one attribute. Dimensions. This is 3 dimension. Ndim is a 2 dimension, right? Same for shape as well. If I just put a1 dot shape. What is the shape of a1? Only 10 rows. This is 1D, right? Only 10 elements. A2 shape is 4 comma 3. A3 shape is 2 comma 2 comma 2, right? Two rows, two table of two arrays of this dimension. Right? Shape is like this. Shape is different from dimension. And then also there's size, right? I just put like size. Size is also one attribute. A1 dot size. Size tell you the number of elements. So it has 12 elements or 10 elements, sorry. A2 has I believe 12 elements. So see, size is the number of elements in that array. Agree? Then there is item size, right? Item size as in A1 dot item size. I believe 8 would come, right? A2 dot each, how much space each element is taking. how much space each element is taking in array. So it is taking just like 8 bits, right? 8 byte of space. And you know in some case it is important factor, because if you just want to just change the space it is taking, how many bytes is taking, I can change that by just mentioning here data type. So by default it takes integer 64, which takes I believe 8 byte. If I just go for integer 32, do it 4 byte. Let me try. Right, by default it takes 8 byte only. And in collab setting, so in different environment setting, you'll find collab it is 8 only. For PyCharm, VS Code, it would be different, right? So data type. Let me just optimize this as well. So you'll get what I'm saying. And that will be np dot. If I just define integer 32, right? So let me check this. A1 dot item size. A1 dot item size. It would come for. Let me see this. I'm able to you know, save the space. If you agree with this, if I can just define this thing, data type, right? Can I change the data type for others as well? Yes. Is there any function for that as well? Yes, there is a function, and the function is s type, right? If I just put a3 s type, right? np dot int 32, I believe syntax is fine. Yes. Now we just go for a3 dot item size. So it would be okay. It has not changed. Hmm. Is it like that? A3 I need to assign? Yes. So that change was not permanent. When I was using S type, that change was not permanent. That is why I assigned it. So now see, you can change the space it is taking from 8 byte to 4 byte just by changing the default setting, which is integer 64. Now I went for integer 32, which take less space because it has less range. So the function is S type. So what is S type? It is a, if you remember, you were changing the data type conversion function, right? Which we have done in Python as well. If you remember, Python inbuilt data structure, string we were changing list as well, right? Data type conversion, typecasting. If it is a yes, give me a thumbs up. I'll pause here for some seconds. Right, folks? Great. Point is just to give you depth with respect to NumPy or with anything, right? Point is now you would think what more into the game. Operations. Let's go. Can we do any operation with this data structure? So array operation, right? There are scalars option, there are operations, there are vector operations. Scalar as in, just you're multiplying things. Okay, I'll show this. First, I'll just create an array. A equal to p dot range 12, right? B equal to np dot range. Say for example for 12 to 24 and dot reshape 3,4. This is A, this is B, right? The thing is, this A, this is B. I can perform some arithmetic operations. Arithmetic operations, as simple as that, multiplying A with something. A multiply with, 3. So every element of that would get multiplied with 3. You can see that. Oh, sorry. This is temporary. So I need to assign A equal to A, comma 3. So see, every value got multiplied with a 3. In fact, for if I just put B equal to 15, what do you think? What would be the output? Yeah, folks. B equal to 15. Is it like every value would get 15? I'm waiting for your response. Line number 54. What sort of operator is this? Is it an assignment operator or is it a comparison operator? False, 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 true. Right? Because this thing might be 15. See? So it is checking each element whether it is equal to 15 or not. Agree? So this operator with this operator. Yes, very good. So yeah, these operations we can run. We can do, right? Plus we can perform some matrix operation. Matrix operation is, or vector operation is just a plus b. Till here I'm just using multiplying or doing any math with just a number. But you can do array and array. An operation between array and array. Mathematical operation between array and array. That can also be done. The shape has to be equal. So let me make C equal to np dot arrange, right? 1 comma, comma, 12. So not reshape 3.4. So this is C. This is C. So you can multiply, add now A plus C. Oh, sorry, B plus C. Again, I'm making the same. So B plus C, right? So you can add them, right? You can add two arrays as well. You can multiply them as well. It's not a big deal, right? So let me just do all these things, more thing to it, like multiply, standard deviation, mean, and all. So let me just go array function, right? So this time I'm creating an array. A1 is equal from np dot random dot random, right? Np dot random. And in this, I'm also mentioning the dimension 3 comma 3. So A1 is this, right? Numbers are very small. They are in decimals. No worries. I can change it. A1 scalar operation we have just learned. So let's apply this application of this use case of this. A1 into 100. So every element would get multiplied with 100, right or not? And over that, I can just make a round. So I can round off it as. So I would get an integer. So every element I multiply with 100 and I'm getting an integer. To make it permanent, I'm just assigning with A1 only. So A1 becomes this. Agree? Easy, right? Now let me show you something. I would take you product, these sort of stuff. Min, max, average, these sort of functions, excuse me. Product sum and all in all. So product variance, standard deviation, or average for that matter. So np dot np dot prod. Yes, prod is the name. You have to prod A1 and now see what I'm doing. Xs equal to 1. Let's go with the sums. If I just put the sum, you can get it more easily. Xs equal to 1. Now see 143. So when I'm saying x is equal to 1, this it is getting summed up like 143, I believe, like this. When x is equal to 1 as in along the row, right? Or along the column actually, but this is a sum of first row, sum of second row. This is coming, right? This is the sum of the third row. Yes, folks. So x is equal to 1 as a row. This row total sum. This row total sum. This row total sum. This row total product. First, second row total product. Third row for total product. Even you can go for np dot sum if I put, and even x is equal to 0. What would happen? Any idea? I'm going to do column wise. First column, second column, third column. See, 161 is the sum of first column. Agree? And 82 is the sum of all the elements in the second column. So this is we can control with this x is equal to this parameter. True? Truly makes sense? Everyone, yes. So I believe now we'll go slowly, but this was my point. Okay. Now by this you can just do anything. You can also find the variance. Do you understand what is the variance? If not, we'll take that separately. Stats class, right? This is equal to 1. So this is a variance. Same, you can apply any mathematical operation like this. Okay. Now let's try to product two dot product, in fact, two arrays. Now you have idea how to dot product any two arrays. In schools, say np dot sig. Let me show you trigonometric function as well. I can also take sine of every value. Sine of what was the even? 32, sine of 43, sine of this, right? Trigonometric function. Yeah, I was talking of dot product now. Dot product. Now you can multiply two arrays, but there's a condition to multiply two arrays. That first array is like 3 comma 4, second array is 4 comma 3, right? So this thing of both should match. 4 and 4 should match. Then the resultant array would be 3 comma 3. So let me know one thing. If I say there is a first array is 2 comma 6, or matrix multiplication you might have done in school, second is 6 comma 1. Can you multiply these two array? Dot product. And if you can multiply, what would be the final array? What is the shape of the final array? Yes, folks. Can you multiply them? Can you dot product these two array? DM yes or no in the chat box. Yes, you can. And final array would be 2 comma 1, right? Can you multiply? This is one array. This is one array. Can you multiply this? Can you multiply this? Yes, you can multiply this. Dot product. Because column, number of column in the first is equal to the number of the row inches. And the resultant array would be this, 2 comma 4. But you cannot multiply this because this is different from this. 6 and 3 are not equal. So this is the logic actually. 2 dot product, 2 arrays. And I'll show you dot product. I'll show you build dot product to array here only. And this is like A is equal to np dot, for example, range 12, right? Reshape 3 comma 4. B is equal to np dot arrange 24, reshape 4, 3 dot a, b. So the resultant would be 3, 3. Let's see. 3, 3. 3 rows, 3 columns. If you agree with this, let me know. Because this array would be like 3, 4. This array would be like 4, 3. So when you dot product them, 4, 4 common. Resultant would be 3, 3. It can be multiply, right? But you cannot dot product when the shape is different. Number of columns in the first, not matching number of the rows in the second. Like A, 3, 4. C, I grade. And P dot arrange 80 dot reshape. It is 3, 6, no? 3, 6. This is C, 3 rows, 6 column, and P dot A, C. Would it happen or would it not happen? The question is to you. So I'll wait for your response. And what would be the output? Okay, do not tell the output. Tell the dimension of the output. A was 3, 4. You can DM me, guys. Can you multiply them? No, this would be an error. Shapes are not aligned. Can you see that? A was this. C is 3, 6. This is not equal to 3. These are not equal. So that's why. Proven. Now, let me also touch indexing and slicing. And slicing arrays. Indexing. So for example, we have array. I believe A was 1D array. No. We create one 1D array. We dot range. Say for example 18. So A is like array having 18 elements in it from 0 to 1. From 0 to 17. A, yes, position here. So if I just put A2, what would come? A2. Yes, folks, everyone, come on. 1 or 2? 2 is coming. Can you see this? And by default, the data type is int64. If you have seen this int64, integer 64, which is of 8 byte. I can reduce the space as like 4 byte by using hash type as well, right? So A2, of course, at the second index, you have 2. This is the 0th index, this is the first index, this is the second index. Now, some of you might be confusing with what to do in this also. Let me just change this something. Say, for example, okay, 12, 24. Sorry, just getting only this in my mind, right? So A2 will be 40, right? So second is the 2 is the index and 40 is the element at that index. 0. So you can do the indexing very easily in 2D. Same as say in 1D array. Same as let's go for a 2D array. And we dot arrange. And this time I'm just going to take 12. Just getting only this number 12. reshape 3 comma 4, 3 comma 4, 3 rows, 4 columns. This is B, right? This is B. Can you tell me the index of 6? You have to tell me this. Index of 6. Yes, everyone. Index of 6. Okay. Others. And these are not clear. Index of 6. Okay. Now the 6 is, I'll tell you, the row and column. Just see the row and column. Yes, you're right, exactly. This is a zeroth row. This is the first row. This is the third row. Of course, first, second, third, three row. 3 rows. But index of the row is 0. In Python, you start with a 0. Unlike SQL, this is 1. This is 2. In fact, in every programming language, sort of high-level programming language, you use indexing start from 0. This is the zeroth row. This is the first row. This is the second row. This is the first column, second column, third column, fourth column. But the index of first column is 0, 1, 2, 3, right? This is the index of column. So this lies at the index of this row, that is first row. Index is 1. This column, 0, 1, 2, second column. Right or not? Let's put it there as well. How we can locate it. So for indexing 1, comma 2. What's wrong with this? Name is B, sorry. I was like, what is the problem? Name is B, right? Can you see this? 6. Int 64 6. Int is like data type. Int and 64 is like its data type. So let me just put print. Then it will not come. 6, right? Tell me the index of 11. Index. Index of 11. Everyone. Guys, yeah, you're not responding. Trust me, response would take us to places. 2, comma 3. Everyone. Okay. Yes, 2, comma 3. Exactly. B. So print B 2, comma 3. Exactly. Second row, third column. Right or not? Second row is in, let's say this is the third row. But index is second. Na? 0, 1, 2. 0, 1, 2, 3. Their intersection. The intersection of 2 and 3 is 11. Right, everyone? Let me do one for 3D. Let me create a 3D array. The 16, 6, comma 3. The 18 is 6, comma 3. So 2, 3, 3 or 3, 2, 3. np dot range 18 dot reshape 2, 3, comma 3. This is 18 only, na? Oh, sorry. This has to be C. So, right. Can you tell me the index of, just put your imagination and tell me the index of 7. 7. Now I'll tell you how. First, you need to feel out of these two array. This array is a one array. This is a second array, right? One array as in index would be 0, of course. The index of this array, this sheet, and this sheet, second array, which is silver 2D array, is 0 and 1. First of all, you have to go to this sheet, 0 sheet. Then you have to go to this 7. How you going to go? 0, 1, 2. Second row, 0, 1. First column. So it will be 0, 2, 1. Agree or not? I'll show you. C 0, comma 2, comma 1. 7. Right or not? Seven. Let's go for 16 now. Or 14 for that one. 14. So 14 is C. Out of the two sheet, which sheet? First, right now. Index wise. This is the 0th sheet. This is the first sheet. First sheet. Then which column? 0 or 1? First row. Which column? 0, 1, 2. Second. So first sheet, first row, second column. Yes, exactly. And the thing is, the point is, I want to emphasize this because I want you to feel it, right? People skip it, but the thing is, then you cannot actually go to the fundamentals, right? First sheet, first row, second column, print, print. And don't worry, this is the last thing, 14, right? I believe indexing is clear with you. For slicing and onwards, we'll discuss the next class. Okay, in the next class, we'll discuss the upcoming part. I believe whatsoever we have discussed today might be clear with you. Okay, folks. Yeah, that's all from my side. I'll share the files with the team. See you. Bye bye. Take care. In case of any questions, you can just let me know tomorrow or afterwards. Bye bye. Take care.